Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay, a meter stick at rest in frame S dash. Meter stick meaning stick of length 1 meter. Okay, at rest meaning that ordinary laws of motion will be applicable here. Okay, because it is primarily at rest. Okay. A meter stick at rest in S dash is tilted at an angle of 30 degree to the X dash axis. If S dash moves at beta equal to 0.8, how long is the meter stick as measured in S? And what angle does it make with the X axis? Okay. Dear students, here one thing needs to be noted, that here only X axis, always X axis or X dash axis is under consideration. Okay, it means while determining the coordinates, y dash will be equal to y. Okay, we will find only X component. Okay, moreover here beta needs to be explained. What is beta? Actually beta is a speed factor. Okay, we know that in relativity the factor alpha is called Lorentz factor. Okay, similarly beta is called speed factor and it is equal to V over C. Okay, anyhow we first try to understand the meaning of V over beta. Okay, we will understand concept of beta from this snapshot. Okay, this snapshot which is regarding length contraction, but it also explains what is beta. Okay, if the relative speed between frames is V, the contracted length L and the proper length L naught are related by L equal to L naught 1 minus beta square whole under root is equal, alternatively equal to, equivalently equal to, is equivalent to L naught over gamma. Okay, we know that gamma is a Lorentz factor where beta equal to V over C is the speed parameter. Okay, so in our statement the term beta has been used, which is equal to V over C is the speed parameter, and gamma equal to 1 over 1 minus beta square under root is the Lorentz factor. Okay, we are well familiar with the Lorentz factor in our previous problems. However, here speed parameter has been explained. Okay, dear students, in order to solve this problem we must develop some foundation. Okay, after developing that foundation it will be quite easier for us to understand the solution and reach its answer. Okay, so as a relevant foundation, these two snapshots have been chosen from different books of calculus, two different books of calculus. Okay, we come towards the first snapshot. Okay, polar and rectangular coordinates, or in other words we can say that relationship between polar and rectangular coordinates. Okay, dear students, here R is a vector. This is x-axis, this is y-axis. Okay, this is pi by 2, that is 90 angle. This is angle theta. This x is equal to r cos theta, and this vertical y component is equal to r sin theta. Okay, point P has both xy coordinates or r theta coordinates. Okay, xy or r theta. While x will be equal to r cos theta, y will be equal to r sin theta. Similarly, tangent theta will be equal to y over x, and hence theta will be equal to tangent inverse y over x. Okay. Similar philosophy is described in next snapshot. Okay, or theta x y or p r theta equal to p x y. Okay, polar and rectangular components. Okay, so one of these are named as polar coordinates and other rectangular components. Polar and rectangular coordinates. Okay, x axis, y axis, x y vector r making an angle theta. Point P has coordinates x y or r theta. Okay, at one time we will consider either of these two. Okay, in terms of other, because we are dealing with the relationship between polar and rectangular coordinates. Okay, from this figure, x equal to r cos theta, y equal to r sin theta. Similarly, r square is equal to x square plus y square. Or if we take under root on both sides, then r will be equal to under root x square plus y square. Okay, similarly, tan theta is equal to y over x, tangent theta is equal to y over x, and hence theta will be equal to tangent inverse y over x. Okay, next snapshot is taken from some book of physics. Okay, not from mathematics, calculus. Okay, and it also conveys almost similar philosophy. Okay, the length and direction of a two-dimensional vector can be determined from its Cartesian components. Okay, a equal to ax square plus ay square under root, and theta equal to tangent inverse ay over x. Okay, next snapshot, some trigonometric values are given. Okay, this table may be very helpful in our further problems, particularly problems regarding vector calculus, vector analysis, etc. Okay, so here we are concerned with the angle theta, angle 30 degree. Okay, so sine 30 degree is equal to half, that is 0.5, and cos 30 degree is equal to 3 under root by 2. Okay, we are concerned with these two values, while all other values may be used in some other problem. Okay, now we come toward the solution in a proper manner. Okay, prior to this we had discussed only snapshots from some books which provide us a foundation to solve this problem. Okay, now we are starting our solution in a formal manner. Okay, in frame S dash. Okay, dear students, in this frame all values will be in terms of L dash, while in frame S all values will be simple, not in terms of dash. Okay, in frame S dash, L dash is equal to 1.0 meter. It is given in the statement, that is meter stick, meaning 1 meter length stick. Okay, theta dash is equal to 30 degree. Okay, angle is given as a 30 degree, but because we are taking into consideration frame S dash, so we will call length as L dash instead of simply L, and theta as theta dash instead of simply theta. Okay, this implies that delta x dash is equal to L dash cos theta dash. This alternative becomes equal to 1.0 meter into cos 30 degree. This becomes equal to 1.0 meter into 3 under root by 2. Okay, because value of cos 30 degree is 3 under root by 2, and hence in this way L dash becomes equal to 0.866 meter. And delta y dash is equal to L dash sine theta dash. This alternatively becomes equal to 1.0 meter into sine 30 theta. We know that value of sine theta is equal to half or 0.5. So delta y dash finally becomes equal to 0.500 meter, that is half meter. Now we come towards frame S. Okay, in frame S, here delta x is equal to delta x dash into 1 minus beta square under root. Frame S, in frame S, rules of relativity, rules of Lorentz transformation will be applicable. Okay, so delta x is equal to delta x dash 1 minus beta square under root. Value of delta x dash we have calculated in the previous part of this problem, which is equal to 0.866 meter into 1 minus beta is given in this statement, which is 0.8. Okay, beta, that is v over c, is provided in the statement, which is equal to 0.8. Okay, next simplification. Square of 0.8 is 0.64. Okay, and when we subtract 0.64 from 1, then we get 0.36, and then when we take under root of 0.36 and multiply it with delta x dash, that is 0.866 meter, then delta x finally becomes equal to 0.5196 meter, and delta y equal to delta y dash is equal to 0.500 meter. Okay, I had explained this thing in the beginning of this problem, that in the whole statement only x axis, x dash axis are under consideration. So y dash will be equal, delta y dash will be equal to delta y. Okay, now tangent theta is equal to delta y over delta x is equal to 0.500 meter over 0.520 meter is equal to 0.96. Okay, when tangent theta is equal to 0.96, then theta will be equal to tangent inverse 0.96. Okay, and it becomes equal to 43.8 degree. Okay, there may be several ways to find out value of tangent inverse 0.96. However, I have taken this value from online calculator. Okay, from Google. Okay, anyhow, you can take this value from some other mean also. Okay, you can also take help from internet. Okay, and L is equal to delta x square plus delta y square. So putting both these values, L finally becomes equal to 0.5204 meter square whole under root, and it finally becomes equal to 0.721 meter. And this is the end of our problem. Till next video, Allah Hafiz.